Good morning. I've been asked to help with number 8 from assignment 5.4. And so, what we have here is something that we can think of as an Atwood machine. And we have a mass that's on the left side that's pulling everything, and we're going to call that direction to the left. And we have a mass on the right side that's trying to pull everything to the right. And then we have a spring that, to begin with, is in the neutral position. So, it's neither pushing or pulling. But because M1 is larger than M2, the whole system is going to go this way until the energy lost by M1, because it's falling. So the energy lost by M1 will be equal to the energy gained by M2 and the spring. We're going to call this height right here our zero height. And this one will fall the same distance that this one rises. And so our distances will be the same magnitude for all three, for M1, M2, and the spring. But M1 will be a negative value, and M2 and the spring will be a positive value. So this is similar to when we were working with Atwood machines earlier. And so we can think of this as an Atwood machine, and we have M1 pulling to the left and M2 pulling to the right. And at first, the spring has no pull. Because M1 is greater than M2, the system is going to move to the left until the potential energy lost by M1 equals the potential energy, gravitational potential energy, and spring potential energy gained by M2. We'll use the starting position as 0. So all of that was stated earlier. So then we look at our beginning equation here, where we're saying we're using the work energy theorem, conservation of energy, probably a better way to say it. And to begin with, we're going to say all three of these energies are 0, because remember, we're calling that height our zero height, and the spring has neither a stretch nor a compression. Will be equal to all of the energies of the three systems final. So then we have 0 equals gravitational potential energy of 2 plus gravitational potential energy of 1 and spring potential energy. So writing in our equation, this is the format we normally see, mgh plus 1 half kx squared. But we're going to use the symbol that was given in the question to make our final format match the format they want for the answer. So we're going to substitute d in for all of those values. So substituting d for all of those values, we get 0 equals negative mgd, because that d is going in the negative direction. It's losing height, plus m2g d2 plus 1 half k d3 squared. As we mentioned earlier, the magnitude of all three d's is the same, but d1 is going to have a negative value like I just stated. So then we're going to add mgd1 to both sides. And we get this equation here, and then we can divide by d, and that gets rid of these two d's and reduces this one from a d squared to a d. And then what I'm going to do is I'm going to subtract m2g from both sides, and I get this equation here. And now all I have to do is multiply both sides by 2 and divide by k, and I end up with our final equation right here, 2g times m1 minus m2 divided by k. Thank you. I hope this was helpful.